Ready to level up your DevOps skills? Welcome to K4 Coding Academy. Master Kubernetes, Terraform, and AI. Get real-world platform engineering projects. Subscribe now and start mastering your future.
Managing AWS infrastructure just got easier with Terraform. Automate, secure, and scale your cloud resources. Learn to provision and optimize with infrastructure as code. Master the future of DevOps. Enroll now.
Welcome to today's explainer, managing AWS infrastructure using Terraform. So whether you're hosting standard web apps or deploying, massive AI models, we're going to use our animated avatars and infographics here to help transform that incredibly complex web of AWS infrastructure into a super clear, unified framework. Seriously, if you've ever felt completely overwhelmed by the sheer scale of managing cloud resources, or maybe you're just looking to absolutely bulletproof your current deployment strategies, well, you are in exactly the right place. Managing infrastructure as code offers some insane benefits. Think better consistency, tighter security, and way more agility. But here's the catch. As your configuration grows, it becomes absolutely crucial to follow best practices so you avoid some, quite frankly, catastrophic pitfalls. Okay, let's take a quick look at our agenda for today's explainer. We'll be covering 1. Structuring infrastructure code, 2. Automating security and linting, 3. Managing and securing state, 4. CI/CD pipeline automation, 5. Scaling to multiple accounts, and finally, 6. We'll wrap it all up with a summary. All right, let's dive right in. Section 1. Structuring infrastructure code, the local workstation. So when you're structuring reusable modules, you really want to aim for a super clean execution. A great example is using an AKS_Carpenter module that points to a very specific source repository. Following AWS prescriptive guidance, your root module needs to be your primary entry point, and you should really lean into these higher-level abstractions. Why? Because by structuring your code this way, and crucially, pinning specific versions, you don't have to constantly rewrite common resources. You're basically describing your infrastructure purely in terms of its architecture, and that guarantees absolute consistency across all your different projects. Now, to build solid guardrails early on your local machine, you really need to implement these exact recommendations. We're talking about requiring tags on all resources so you can actually track your costs, and restricting instance types to completely stop build shock right in its tracks. You also need to enforce mandatory variables so your deployments don't just randomly fail. And as an absolute baseline, every single developer has to format all their files with the Terraform FMT command to match HashiCorp style standards, and then verify that overall structure with Terraform Validate. Getting these basics right out of the gate isn't just about clean code. It literally massively accelerates how fast you can onboard new developers. Moving right along to Section 2, automating security and linting, catching errors early. To build your ultimate security toolkit, you really need a multi-layered approach. Look, you can't just run Terraform and cross your fingers. You have to scan it. First up, you'll want to use TFLint. This is your go-to for catching AWS-specific errors, deprecated syntax, and any unused declarations. Then we step it up to TFSec for dedicated security scanning. This is going to find things like exposed ports or missing encryption. And finally, Checkoff is your heavy hitter for deep IaC compliance. It's looking for really complex misconfigurations that go against your organizational policies long before you ever hit deploy. Using this trio together means you are building rock-solid, trustable, production-grade infrastructure. Let's keep going. Section 3, managing and securing state, the cloud backend. Okay, I want you to think of state as Terraform's literal memory. It's the vital bridge connecting your text files to the real, breathing infrastructure actually running in your cloud account. Without this state file, Terraform is totally blind. It has absolutely zero idea if that EC2 instance you just defined already exists, what its ID might be, or if it needs to be spun up completely from scratch. Because of that, keeping your state strictly local is a recipe for absolute disaster. Just imagine 2 developers running Terraform apply at the exact same time and completely corrupting the state. Or what if someone's laptop gets smashed and it happened to hold the only copy? Even worse, imagine accidentally committing it to Git and exposing all your database passwords and secrets to the world. Yikes. The ultimate solution here is a remote S3 backend. It gives you version storage, it's totally centralized for the whole team, and it uses DynamoDB atomic locking to stop those simultaneous conflicts dead in their tracks. So what does this actually look like in your code? Well, it means declaring a backend S3 block. You're going to specify your organizational bucket, the key path, and the region. But the real magic here is that use lockfile equals true parameter. This leverages native locking capabilities. So when you run an operation, Terraform physically locks the state. Nobody else can mess with it at the exact same time. This one simple block of code completely eliminates state corruption for your entire team. A real game changer for sure. Next up, Section 4, CI/CD pipeline automation, deploying with confidence. Listen, a properly configured CI/CD pipeline completely eliminates that dreaded "works on my machine" excuse. You know the one. Instead, when a developer opens a pull request, your automated workflow takes the wheel. It runs a plan, posts the results right there as a comment, and when you finally merge, those changes apply automatically to AWS. It's predictable, it's repeatable, and it is heavily, heavily audited. A truly production-ready GitHub Actions workflow follows these precise sequential steps. First, obviously, we check out the code. Then we configure our AWS credentials securely using OIDC, so absolutely no static passwords floating around. Next, we set up Terraform and run those format and validate checks we just talked about. But hey, pay really close attention to these final steps. It is a non-negotiable best practice to separate your permissions here. Your plan job, it must only have read-only access to your AWS account. It's just peeking at what will change. Only the final apply job, which runs after merging to your main branch, should ever have the actual right access to modify your infrastructure. All right, on to Section 5, scaling to multiple accounts, enterprise governance. So here's a big question for you. How do we scale this secure, automated infrastructure across an entire enterprise? Because let's face it, as companies grow, they naturally start adopting multiple AWS accounts. You need them for security isolation, billing separation, and frankly, to reduce the blast radius if something goes terribly wrong. You might have entirely separate accounts for dev, staging, prod, shared services, security, the list goes on. So how do we manage all this immense complexity across dozens of isolated accounts without driving ourselves absolutely crazy duplicating code? Well, the answer lies in combining 3 incredibly powerful layers. First, you start with AWS organizations to centrally manage all those accounts. Then, you implement service control policies, or SCPs. These act as strict organizational guardrails, basically defining the maximum possible permissions any account can ever have. Finally, for your Terraform code itself, you wrap it in TerraGrunt. TerraGrunt is this awesome thin wrapper that provides dry, don't repeat yourself configurations. It handles dependency management across all those accounts and ensures your environments, whether it's dev, staging, or prod, remain perfectly isolated but super easy to deploy from one single unified structure. And that brings us to Section 6, Summary. I want to leave you with this really powerful quote from our source material. A poorly designed pipeline can deploy broken infrastructure faster than any human ever could. Let that sink in. Ultimately, automation is a massive amplifier. If you just rush headfirst into setting up CI/CD without the proper module structure, without local linting guardrails, and without securing your state in a locked S3 backend, you are literally just accelerating your mistakes. But on the flip side, if you follow the blueprint we outlined today, you gain immense speed, absolute security, and total confidence in your cloud architecture. Like we just said, automation is a massive amplifier, but it only amplifies what you already have. So ask yourself right now, is your current pipeline deploying secure, modular infrastructure, or is it just helping you deploy broken code faster? Ponder that for a bit. If this explainer helped you master managing AWS infrastructure using Terraform, be sure to like, share, and subscribe to our channel for more awesome content. We will see you in the next one.